This question says, a chemical engineer is studying two reactions shown in the table below. In each case, he fills a reaction vessel with some mixture of the reactants and products at a constant temperature of 42 degrees C and a constant total pressure. Then he makes reaction enthalpy and reaction entropy of the first reaction and the reaction enthalpy and reaction free energy of the second reaction. The results of the measurements are shown in the table below. So that's what we have here in these two tables. Essentially, what our goal is to two things. One, figure out the missing variable, and two, decide which process is spontaneous, the forward reaction or the reverse reaction. If you'll recall, delta G tells us whether the reaction is spontaneous or not. If it's negative for the reaction as written, the forward reaction is spontaneous. If it's positive, then the reverse reaction would have a negative delta G, and therefore the reverse reaction is spontaneous. So put simply, if delta G is negative, the reaction is spontaneous. So how do we calculate that? Well, free energy takes into account both the enthalpy and the entropy. And it is delta G equals delta H minus T delta S. And this has to be, sorry, I didn't mean to say that. So basically what I was getting at is the units. So what we have to be careful of when we're doing this for the first reaction, where we're given delta H and we're given delta S, is that the delta H is in kilojoules, and the delta S is in joules per K. So we do need to make sure that the units match in order to make sure we get the right answer. So what I'm going to do is I'm going to put delta G equals minus 439 kilojoules minus the temperature, which has to be in Kelvin, 42 degrees C converted to Kelvin, add 273 to it, which is 315 K, times, now instead of negative 1393 joules, I'm going to divide that by 1,000 and put it in as negative 1.393 kilojoules per K. When you do this, you're actually going to find out that this equals positive 439. So in this case, delta G actually equals 0, which is probably pretty atypical. But in this particular case, delta G happens to equal 0. When delta G equals 0, neither reaction would be spontaneous because neither one has a delta G that is negative, because delta G is exactly 0. But I should note, this is more of an exception or a rare case than the rule. It's usually a little bit negative or a little bit positive, at least. Sometimes it's very negative or very positive. Next, let's look at the next one. In the next case, the variable is delta S. We're given delta G and we're given delta H. So we're using the exact same equation. Delta G equals delta H minus T delta S. This case, we have the value of delta G. It's 31 kilojoules. We also have the value of delta H. It's 1,648 kilojoules. Minus T, which is still the 315K, times delta S, which is the variable. That's the thing we're trying to find. So the first thing we want to do is subtract out the 1648 kilojoules from both sides. There it cancels, and then we do minus 1648 kilojoules over here. And what we find is that negative 1617 kilojoules equals negative 315 K times delta S. Now we want to divide by the negative 315 K, divide by negative 315 K, and what we find is delta S equals 5.133333 kilojoules per K. Notice, again, it asks for delta S in joules per K. So we need to take this and multiply by 1,000. So this is or 5133 joules per K. So the answer here is 5133. Next thing, which reaction is spontaneous, the forward reaction or the reverse reaction? You're actually familiar with this reaction. The reverse of this reaction is iron plus oxygen equals rust. So we know that the forward reaction here is spontaneous, right? If you leave the car and you don't do anything to it, it slowly rusts. You do not have rust forming back into nice iron metal and oxygen gas. So we know the reverse reaction is spontaneous. But what tells us the reverse reaction is spontaneous? Well, delta G is positive. So for the forward reaction, it's not spontaneous because delta G is positive. But for the reverse reaction, delta G is exactly the opposite, minus 31 kilojoules. So for the reverse reaction, delta G is negative. So the reverse reaction is the spontaneous reaction in this case. And I just want to remind you one more time, because this is very common, when you're using the formula delta G equals delta H minus T delta S, it's very common for delta H to be given in kilojoules and delta S to be given in joules per K. So make sure you make those match up so that you're not adding joules and kilojoules together, because if you do that, you're going to unfortunately get the wrong answer.